Hello everybody and welcome to Science with Miss Andy. Today we'll be talking about physical science, specifically motion and stability for you fifth graders. Some of the things we will be learning about are the gravitational force of Earth acting on an object near the Earth's surface, which pulls that object towards the planet's center. Objects can exert force upon one another, such as elastic pushes and pulls, as well as friction. Some objects don't need to be in contact in order to exert force. Some examples of the distance exerting force upon another object include magnetic, electric, and gravitational forces. In this presentation, we will be looking at the gravitational force of the Earth and pulling objects towards its center, as well as Sir Isaac Newton's 3 laws of motions. Some vocabulary that you will be needing for the next upcoming weeks include momentum, which is the motion growing stronger and stronger as time passes, acceleration, which is the increase in the amount of speed, inertia, the tendency of an object to resist change in motion, velocity, which is the speed that something travels, gravity, which is the force that pulls objects to the Earth's center, force, which is a push or pull exerted on another object, friction, which is force exerted by two surfaces rubbing together, and mass, which is the weight and size of an object. Before we begin, I'd like to give you some background on Sir Isaac Newton. Sir Isaac Newton lived between 1642 and 1727. He grew up on a sheep farm near London, England, and went to the University of Cambridge, where he became a mathematician and developed calculus. He discovered the force of gravity when he was sitting underneath a tree and was struck in the head by an apple, wondering what would have caused the apple to fall in a downward motion. He also developed the theories about movement, which are known as the 3 laws of motion. The first law of motion states that objects at rest tend to stay at rest, and an object in motion tends to stay in motion with the same speed and direction until a force acts upon it, changing either the speed or direction. Meaning, if an object is not moving, it's going to continue to not move until something either pushes or pulls on it, known as a force. On the other hand, an object that is moving will continue moving at the same speed and direction until another force stops it or changes its direction. The second law of motion states that the greater the mass of an object, the more force it will take to move it. Additionally, the acceleration of that object's movement is related to its mass and the force enacted upon it. Meaning, if an object is really heavy, it's going to take a lot more force to get it moving than if it were lighter. And if an object is lighter, it's more than likely going to be moving faster, given the same amount of force as it would have on a heavier object. The third law of motion states that for every action or force, there is an equal and opposite reaction. Meaning, if an object is moving in one direction, there is a force moving in the opposite direction. Some of this was seen in the centers that we conducted earlier in our exploratory phase. In the first center we pushed balls up a ramp. This demonstrated Isaac Newton's first law of motion. The ball was still until we pushed it. Once we pushed it, giving it force, it rolled up the ramp. In center number 2, you guys were pushing balls of different masses. A bowling ball, which has a lot greater mass than a tennis ball, took a lot more force to get it moving. Additionally, if you would have given the same force to push the bowling ball versus the tennis ball would have gone a lot further. In our third center, we blew up balloons, and without tying them, we let them go and watched them change their directions. What does all of those centers have to do with the gravitational pull of Earth? I'm so glad you asked. Earth's gravitational pull. When you rolled the ball up the ramp, what happened? The ball rolled back down. Why? Because the gravitational pull of the Earth brought it back down towards its center. When you pushed the sports balls of different mass, what happened? The balls with greater mass took more force to move. The Earth has more mass than objects on it. Therefore, it has the stronger force to pull objects back to its center. When you blew up the balloon and let it go, what happened? It pushed away from you, or the direction you released it in. When we jump, sit, swim, or drop objects, what's to keep us or those objects from floating away into outer space or continuing to float? The answer is the Earth's gravitational pull. Because the Earth's mass is so great, it has a stronger gravitational pull on the objects on its surface, which not only prevents these objects from either flying away, but it also says that whatever goes up must come down. Meaning if we jump, we're not going to continue to go up. We're going to be brought back down to the Earth's center. Now, down is a relative term because things do not move in a linear up and down type motion. Because if I jump in California, I'm not going to move in the same direction that somebody in northern Canada would move. Essentially, we are all going up wherever we are and being pulled back to the Earth's center based on our geographical location. That's just a little explaining before we continue on with our lesson. Thank you.